In section 8-5, we're looking at some applications of trigonometry, and a concept that's brought about and is in your notes that you've received is that of angle of elevation and angle of depression. And we're going to look at an example of each of those kinds of problems here. So in this particular problem, we're told that according to a Chinese legend from the Han Dynasty, 206 before the Common Era to 220 of the Common Era. Common Era is how we're grading our numbering our years now. General Han Qin flew a kite over the palace of his enemy to determine the distance between his troops and the palace. If the general let out 800 meters of string and the kite was flying at a 35-degree angle of elevation, how far away was the palace from General Han Qin's position? Now, part of this problem is a little contrived because the metric system, first came out at the time of the French Revolution, and that was much, much later. Probably wasn't true that the Chinese people at that time used degrees for angle of elevation, but just so the problem makes sense for our use, that's how we're going to set this up. So, here's the ground, we have the palace, and I'm probably not drawing a very accurate picture of a Chinese palace. Apologize for that. But we have the general over here, our little stick figure guy, and he has the kite string so that his kite can have a tail on it, is flying above the palace. And we know that the angle of elevation, so an angle that goes upward from a horizontal, is 35 degrees. Now, the general wants to know how far from the palace he and his troops are, so we want to know the length of this segment that I've kind of highlighted in red there. Now notice if I go directly toward the ground from the kite, that we've formed a right triangle, where this distance along the ground to the palace is one leg, the distance from the ground to the kite is another leg, and the string would act as a hypotenuse. Now, we do know that the general let out 800 meters of string, so the 800 meter distance would be on the hypotenuse of that right triangle. So, if I want to try to find the distance of the general and his troops from the palace, let's say that distance is defined by the variable d. So, d is equal to the distance to the palace. If I see how these three quantities are related in this right triangle, and just again to make sure we're seeing the right triangle part, even though that is kind of an imaginary segment from the kite to the ground, here's the string, here's the distance along the ground, forming that right triangle. Well, relating this angle and these two distances, notice for this 35-degree angle, this distance would be the adjacent leg in the right triangle, and because this is opposite the right angle, 800 meters represents the length of the hypotenuse. So if I can remember our little memory device, remember eventually this is going to expire. We're going to let that go. But for right now, if I have adjacent leg and hypotenuse, that's this one. That's the cosine. So my equation, I'd have cosine of 35 degrees is equal to the adjacent leg, the length of D, divided by the length of the hypotenuse, which is 800 meters. Now, that equation is not solved for our variable yet. Notice we have D divided by 800 meters. Well, to undo division, we multiply. So if I multiply both sides by 800 meters, our equation would become D equals 800 meters times the cosine of 35 degrees. So now that equation has been solved algebraically for the variable. The variable is all by itself, equaling everything on this side. Now I'm ready to use my calculator. So if I get my calculator out here, turn it on. I'm going to zoom in a little bit here just so you guys can see everything. But notice that the screen does show that my angles are going to be interpreted in degrees. So this is the kind of calculator where I don't see everything. So when I put 800 times the cosine of 35 degrees in, I'm going to do 800 times. Now I hit the 35 and then the cosine key. Now that's just the cosine of 35 degrees. I still have to hit equals to get my final value. So if we look at that, it's about 655 and 3/10 meters then for D. And notice I left my label on my number there. That way, oh, I know it's got to be in meters. So D is about 655 and 3/10 meters. So to answer the question, Han Chin and his troops are about 655 and 3/10 meters from the palace, or about 2/3 of a kilometer, roughly. Now, let's look at a second problem. In this problem, we're told that salvage ship's sonar locates the wreckage at a 12-degree angle of depression. Okay, sonar is a device that sends out sound waves through the water, as opposed to radar, which sends radio waves through the air. Okay, we're told that a diver is lowered 40 meters to the ocean floor. The question asks then, how far does the diver need to walk along the ocean floor before she reaches the wreckage? Now, the cool thing about these kinds of problems, folks, is that you get to draw cool pictures. So now we have a ship, which would be on the surface of the ocean. Okay, and you have the ocean floor below, and you have some wreckage. So maybe this was an old sailing ship. So the masts are all twisted and everything, and here's the chain for an anchor. Okay, and we know that that ship is sighted by the sonar at a 12-degree angle of depression. So that word depression means an angle going downward from a horizontal. Well, the surface of the ocean here is our horizontal, and so here would be our 12-degree angle of depression. Notice going downward from the horizontal. Now our diver is lowered from the ship a distance of 40 meters. So here's the diver, and it has the diver is wearing one of those diving suits. It has the big heavy helmet on it. So you get to draw all this kind of stuff, and wearing the suit with the big heavy boots so that she'll sink to the bottom, won't float around, even though there's a hose that comes down along with that provides air, and so the suit's full of air, and if it's not weighted down, then she'd be floating all over the place. So it needs to have some weight to hold her down there. Now, what does our question ask? Well, she was lowered 40 meters. It was a 12-degree angle of depression. So this distance is 40 meters. How far does the diver need to walk along the ocean floor before she reaches the wreckage? So again, kind of highlight this in different color. We need to find that distance. And so she would have dropped a distance of 40 meters, which would be perpendicular to the ocean floor. So we have a big right angle there. And so we have this right triangle. Now, first glance, we'd say, well, this 12-degree angle of depression isn't even in our triangle. What am I going to do? Well, there are a couple of moves. Remember the horizontal representing the surface of the ocean and the horizontal representing the floor of the ocean are parallel lines. And so this sonar reading traveling linearly from the ship to the wreckage would act as a transversal, which means that alternate interior angles are congruent. So one way of doing this would be to say, well, if we have a 12-degree angle of depression from the ship to the wreckage, there has to be a 12-degree angle of elevation from the wreckage looking back upward toward the ship. Because that idea that if two parallel lines are cut by a transversal, alternate interior angles have to be congruent. So that was one way. The other way some people would approach this is saying, well, I would know this is a 90-degree angle, so if that's 12 degrees, we could find this to be a 78-degree angle, and that's fine too. I'm going to stick with the 12-degree angle that I have. So again, we want to know how far the diver needs to walk along the ocean floor. I'm going to use W for walk. Could have used any variable I want to. So we know W stands for the distance to walk. So in my right triangle here, 12 degrees, that's the adjacent leg. It's one of the sides that makes the right angle here. The 40-meter distance would be the opposite leg. So just reviewing, which of those have the adjacent leg and the opposite leg? It'd be this one, opposite leg, adjacent leg, which is for the ratio of the tangent. So we'd have the tangent of 12 degrees is equal to the opposite leg, which in this case is 40 meters, divided by the adjacent leg, which for this problem is W. So now, how to solve for W? Not going to use my calculator yet. Remember, if I divide by W and get the tangent of 12 degrees, I can use the same numbers to say, well, if I divided 40 meters by the tangent of 12 degrees, I'd have to get W. Remember, a divisor and the quotient are always interchangeable quantities. So I could say I know that W has to equal 40 meters divided by the tangent of 12 degrees. Now I'm ready to use my calculator because I've solved my equation algebraically for the variable. So now I'm going to get my calculator out again. I'm going to zoom in a little bit. I'm using the calculator that doesn't show me everything that's going on. So I'm going to have 40 divided by, I'm not going to do the tangent because then it would take the tangent of 40 degrees. So I did divided by, so now I'm going to do 12. Now take the tangent. Remember, that number just represents the tangent of 12 degrees. So then I have to hit equals to find out what 40 divided by the tangent of 12 degrees would be. So rounding to the nearest tenth, it's about 188 and 2/10. It's hard to see there, but there's a decimal point. So W is approximately 188 and 2/10, and I left my label in there so I wouldn't forget about it. And so our answer to the question would be then the diver would need to walk about 188 and 2/10 meters along the floor of the ocean to reach the wreckage. Okay, we are expecting you to write out your answers in sentences here, folks. Part of this is a communication thing. Remember, thinking about a word problem given to us in sentences, our answer should be written out in sentences. So basically, it's just restating the question as an answer. How far does the diver need to walk along the ocean floor before she reaches the wreckage? The diver would need to walk about 188 and 2/10 meters along the floor of the ocean to reach the wreckage. So it's just rephrasing that question into an answer. Those are the two problems.